Today, we're going to create a rain on the lens effect in Unity and in Unreal. Let's go. So we're going to start out in Unity today. And I've already gone over the process of setting up things for doing post-processing effects in episode 49 of this series. You can see a link to that right here. So I'm not going to go over the full setup of that because you can watch it in episode 49. But I will say we have our custom pass volume object here. And you can see that we've got it set up so that our shader is writing to a custom color buffer. And then we're reading that custom color buffer back and writing it out to the camera. So that's the basic setup. So this is the material that we're going to be working with today. You can see that it's called Test Full Screen Rain on the Lens. So let's just take a quick look at this. You can see that it's not doing anything yet. All I'm doing is taking our color and writing it out to the custom buffer. And I'm using the screen position to sample our color. Now, if we want to add rain to the lens, we need to distort our texture coordinates, our screen position values here, using those raindrops. And so that's what we're going to be focusing on. We're going to create a new subgraph that does that distortion, and then we're going to add it to our screen position coordinates here. So I'm just going to add a new add node, and we need to create a new subgraph that will set up this distortion. So I'm going to come down here to my shaders weather folder, and we're going to create a new shader graph subgraph, and we'll call this raindrops on the lens. And let's open this up and get started. All right, so our output is going to be UV distortion. So I'm going to pick my graph inspector here. We're going to set our output to be a vector 2 because we're going to be offsetting the UV coordinates of the screen. And let's name this rain distortion. And what I'm about to show you is very similar to a rain effect that I created way back in another series in episode 14. I'll link that one right here so you can take a look. This is really similar to that. We're just adapting it for full screen instead of applying the rain to the surface of our objects. So we're going to use the same texture that we used for that effect. And here it is. Here is our raindrop texture. Let's just take a look at this texture really quickly, and I'll walk you through the information or the data that we're storing in each of these channels. What I've managed to do is create a raindrop effect that just uses one texture, and all the data is packed into this single texture. So first of all, in the red and the green channels, we have the normal data. You can see that I've got, for the Y, I've got the up and down normal data, and for the X, I've got the left and right normal data. Then in the blue channel, I've created this mask that is a temporal offset. So each one of these drops has a different shade of gray in the blue channel. And what that allows us to do is animate the drops where each drop is happening at a different time. And then finally, in the alpha channel, I have a mask where the white areas are drops that are going to be animating, and the black areas are drops that are going to be static. So we have both static and dynamic masks here packed into a single channel. And I'm going to go through the process of showing you how we unpack all of this data to animate our raindrops. The first thing that we need to do is sample our raindrop texture. And so for that, we're going to grab our screen position, and we just want the screen position's X and Y values. So I'm going to add a swizzle node, and we'll take just the X and the Y. And if I pass this out and sample our coordinates. Actually, let's just go ahead and do that. So we've sampled our texture. We're going to pass out our texture values as our rain distortion. And then we're going to add this subgraph to our main shader. So here's our raindrops on the lens subgraph, and you can see that it's writing out our texture data. And if we pass this into our color, now we can see what our scene looks like with just that texture data. So that's pretty cool, but one thing that I see that's a problem is that our raindrops look a little bit stretched. Let's switch back to our raindrops on the lens subgraph and just wire in the screen position data and see what that looks like. So the screen position data goes from 0 to 1 vertically, and it also goes from 0 to 1 horizontally. But you can see that it's not square. It's actually going across the entire screen. And our screen is not a square aspect ratio. So if we want to sample the texture and keep our pixels in the texture square, we need to adapt this screen position data so that it's square instead of longer on the horizontal axis than it is on the vertical axis. So let's go ahead and do that. We have our screen position here. And now what we need is the size of our screen. So in Unity, I can bring in this screen node, and you can see that now we've got the width and the height of our screen. And so what I'm going to do is divide the width by the height. And this will give me an aspect ratio. So a 16:9 aspect ratio, the result of this will be something like 1.77 or something like that, approximately. So now what I want to do is multiply this data by this, but I only want to multiply the x by that, and I want to multiply the y by 1. So what I can do is add a combine node, and we're going to take the value of our screen divide, and then for the green channel, we're just going to give it a value of 1. And now I can take this and multiply it by our screen position coordinates. And now I've got screen position coordinates that are square. So if we wire this into our rain distortion, actually, just to make it a little bit more obvious, I'm going to add a frac node here so that you can see what this is doing. So let's wire this out and take a look at what this looks like in our scene. Yeah, there we go. Now you can see that I've got my square texture coordinates. And if I use these to sample my raindrop texture, we'll be able to get raindrops that are using the proper aspect ratio. So let's take a look at this. And there we go. So we've got our raindrop texture applied to the screen, and our drops are no longer being stretched because we have more pixels horizontally than we do vertically. Okay, so we're making some good progress. That's our first step to set up the texture coordinates for our texture. The next thing that we need to do is split out all the various components of this texture. First, I can take the X and the Y, so I'm going to add a combine node here. I want X and Y, and I also want the alpha. Now, if you'll remember, our alpha is that map that is determining the animated drops versus the static drops. So we're going to wire that into our blue channel of our combine. And what we want to do with this data is expand it. So we're going to multiply it by 2 and subtract 1. And what that's going to do is change our range from 0 to 1 to -1 to 1, which is going to give us correct normals. All right, so we've expanded out our data, and now we can just take the normal portion of the data, which is the XY, And this is the result that we're going to be passing out. So let's go ahead and pass this out as our distortion. And we'll save this and take a look at our screen. And you can see that we're getting our raindrop textures. Well, let's go ahead and use this to distort our texture coordinates and see what we get. So here's our raindrops on the lens subgraph that we've been working on. And we're going to go ahead and add the offsets to our screen position coordinates and then use that to sample our scene color and then pass out the result of our scene color. And this is just an intermediate step, but I want to take a look and see what happens when we use our raindrops on the lens added to screen position and then used to distort our scene color. So let's save that and take a look at our scene. And wow, there's an awful lot of distortion going on here. And we can fix that if we just multiply the output of our raindrops on the lens by some really small numbers. So let's multiply our output by 0.03 just to tone down how much distortion is happening, and pass that in and hit save. There we go. Yeah, now you can see that our raindrops are distorting our scene, and the areas where we're getting drops are kind of acting as little lenses and distorting the scene so that it looks like there are raindrops on the lens. Well, that's pretty neat, but our effect isn't animated yet. So we need to switch back to our subgraph and add some animation into the effect. So in order to get animation, we need a time node. So I'm going to bring in time. And to control the speed of time, I'm going to multiply it by 1.5. Just to kind of speed the time up a little bit. And now we're going to take this blue channel of our texture that we haven't used it yet. Now remember, this blue channel contains our temporal offset mask. And so I'm going to use that temporal offset mask, and we're going to subtract time from it. And what this is doing is it's going to scroll through that mask using time. So every drop is going to be slowly changing from 0 to 1, 0 to 1, 0 to 1 over time. But because we're using this offset mask, each of the drops is going to be slightly different. And so I'm just going to take the fractional part of what's left, and there you can see what I'm talking about. So each drop is slowly transitioning white to black, white to black, white to black. Okay, now we need to use the mask that we created in the alpha channel that determines if the drops are static or animated. And so we've expanded that mask here by multiplying by 2 and subtracting 1. And so now that mask has animated drops as white and static drops as -1. And so we need to unpack that data. So I'm going to come down here and add another swizzle node. And we're just focusing on the Z here because this is our alpha channel where our drops mask is, and we put it in the blue channel here. So we're going to pull it out of the blue channel here again. So in order to get the animated drops, all I have to do is saturate this. And what that's going to do is it's going to get rid of anything below 0, including our static drops mask. So there is the mask for our animated drops. And if I just take our animated mask here and multiply it by our animated drops mask, now we're going to have a really nice animated drop effect. And I can use this and multiply it by our normals to animate the drops. There we go. So anything that's not a drop is getting masked out, and each individual drop is animating by itself. That's pretty cool. So let's pass the result of this out and take a look at what we're getting on our screen now. There we go. We've got some cool looking animated drops. Now we haven't added in our static drops yet, so let's do that next. We'll switch back to our subgraph here, and we're going to take the result of our swizzle here and add a negate node. Now remember, here we have our animated drops as white, and we have our non-animated or our static drops as -1. So when we negate it, now our static drops become white, and we can get rid of the animated ones by adding a saturate here. So now, if we add the results of our animated drops and our static drops together, we end up with our final mask. And then we use that mask to multiply our normals and take a look at our scene. Now you can see that we've got a nice combination between animated drops and static drops. All right, pretty cool. So we've got animated drops and static drops, and you can see that it's a pretty convincing, nice looking rain on the lens effect. To go back to our main shader, you can see that we've got our raindrops on the lens effect here, which is creating that rain distortion. Then we multiply that by 0.03 just to tone it down. And then we're adding that to our screen position values and using those values to look up our final scene color and then passing that out. And then here in our raindrops on the lens effect, we're sampling our drop texture and using the various values of the texture to create the static and animated drops, and then passing that data out as distortion that we can use to distort our screen coordinates to look up our full screen color. Okay, so that's the effect in Unity. There is one thing missing though. It would be nice to have some little drops dripping down the screen as well. And that's the effect that we're going to go over next week. So be sure to come back next week for that one. And in the meantime, let's switch over to Unreal and I'll show you how to create the same effect in that engine. All right, here we are in Unreal, and we're going to take a look at how this raindrop effect is created here. First of all, in our scene, we have a global post-process volume. If I come down here to the settings of the global post-process volume, you can see that under rendering features, post-process material, there's an array of materials. And here I've added one element to that array, and I've added this test post-process rain on the lens material to my global post-process materials. And that's what creates the effect here. So let's go ahead and take a look at the shader that I've created so that we can see how this is working. So this is very similar to the way that we set up things in Unity. I created a material function called weather screen drops. And we also created one called weather screen drips, but this is the one that we're going to go over next week. So let's save that one for later. So for weather screen drops, we take the data coming out of that, multiply it by 0.03 just to tone it way down. And then we add that to our texture coordinates, which in this case is the coordinates on the screen. Then we use those coordinates to look up our scene texture post-process input 0 value. And that is the data from our screen. And we pass that in to get our final result. So really what we need to look at is what's happening in here in weather screen drops. All right, just like we did in Unity, we're sampling the same drop Texture. And by the way, I'll put a link to download that texture in the description. So we take our screen resolution. Here's our visible resolution, our width and our height. So here's our width data and our height data, and we divide the width by the height, and that gives us our aspect ratio. Then we append 1 and we multiply that by our texture coordinates. And what we're doing with this is just creating square texture coordinates so that we can sample our drop texture the way that we intended. Then we multiply our texture coordinates by 2 just to get our drops to be a size that we like. So then we sample our texture, and we take the red, green, and alpha channels and combine them together. And then we multiply by 2 and subtract 1. Again, this is expanding the range of that data from the 0 to 1 range as it's stored in the texture to the -1 to 1 range that we need in the shader for the normals. Then we take our normal data, which is in the red and the green channel, and we pass that out, but not before multiplying it by our mask. So let's go over how that mask is created. So first of all, in order to animate the drops, we use time. And we're multiplying time by 1.5 here just to change the speed up a little bit. And then we take our offset mask, which is stored in the blue channel. So every drop has its own shade of gray, and that is offsetting each drop. So they're, instead of being animated all in unison, they're animated all offset from each other because we have each drop has its own unique shade of gray. So we take that value and subtract time from it to get something that is animated. And then we take the fractional portion of that, and you can see here that now we have our animated drops. Then we also need our drop mask, and our drop mask is coming here from the alpha channel, and we're expanding it out by multiplying by 2 and subtracting 1. The reason that we're doing this is because our drop mask is storing the animated drops as white and the static drops as black. And so what we're going to do is when we multiply by 2 and subtract 1, now our animated drops are a value of 1, and our static drops are a value of -1. So then we take the blue channel here, where we've passed our alpha channel, and by saturating it, we've gotten rid of the static drops. And then, so this is our animated drop mask, and we can multiply our time offset here. And what we get here is our animated drop mask. And now we need to combine it with our static drop mask. So our static drops here are a value of -1. So if we multiply that by -1, we get a value of 1. So we've flipped our mask over so that now our static drops are white. They're on top. Now we need to add a little bit of an adjustment here and saturate it so that what we're left with is our static drop values. And that's what you can see here, our little tiny red dots. Okay, then we add our animated drops and our static drops together to get our final mask. And then we multiply that by this is raining value. This is optional. This is just something that you can use to turn the rain on and off if you want to. So that gives us a mask where we have static drops, animated drops, and then we can set this input value to 0 or 1 to turn the drops on and off. Okay, then we multiply our normal values by our mask values to get the final output of our drops, and we pass that out as our normal. We also have an output as a mask here, and this mask is our static and animated drops, but in this case, we're not going to use that for our effect. Okay, so here is our material. You can see that we're normalizing our texture coordinates here so that they're nice and square instead of stretched. Then we multiply by 2 just to make the drops a little bit bigger. Then we use that to sample our drop data. And then we expand our drop data. We get our final normal and multiply it by the mask that we created of our static and dynamic drops. And then we pass that out. Cool. So we've created our nice distortion data. And then we can use that data here to add together with our texture coordinates and then sample our final post-process input 0 or our scene color data. If we just wire our texture coordinates as is and we save that, you can see that now our effect has gone away because we're just taking each of the pixels in our off-screen buffer and sampling them as they are. But what we can do is take this animated offset data that's coming out of our weather screen drops material function, and we get this value here, and we're going to use that to distort our UVs. But first we need to tone it down, so we're going to multiply by 0.3. Then we're going to add it to our texture coordinates and use that to sample our final color data. And there you have it. We have nice drops on the lens. Okay, as I said before, next week I'm going to show you how to create the drips coming down the sides of the lens. So be sure to come back for that. Thanks a lot for watching, everybody, and I hope you enjoyed the video today and that you have a great week.